Okay, so today we're going to learn about rocket propulsion. And we're going to learn basically how some of the fundamental laws of nature can help us describe the way a rocket moves. Please sit up. And also how chemical reactions can help fuel the rocket. So before we get started anything else, there's a couple of words that we need to know in order to really understand what we're going to be doing. So one of the main words we need to know is force. This is something we may have learned before. So I want you to take 30 seconds, and I want you to think to yourself right now what the word force means. And maybe you can write it down on your paper. So we're going to write the word force on your paper. It's written up here on this board. See? And then you can draw pictures or write down what you think it means. And don't show anybody your work right now, because I just want to know what you know. If you don't know it, that's okay. Just think about what you think it means, right? Maybe you've heard it before somewhere else. Oh, it's right here. F-O-R-C-E.
That was an S.
Okay, we're going to do about 10 more seconds to come up with something you know about force. Okay, if we don't know it, so that's fine. We'll hopefully learn it, okay? All right, so what I'd like us to do is maybe Ty, you can go first. I see you drew a picture. Can you describe your picture? It's a person pushing something, okay. So what is that? How does that have to do with force? Why does that represent force? He's putting a force on the thing that he's pushing, okay. And then Mary, what did you put for your force?
Using strength to make things move.
Okay, moving strength to make things move. See, based on what they said, can you think of what a force is? Can you give an example of a force? Can you show us a force? Okay, so let's listen to our classmates' responses again, okay? And then you can use what they said to help you understand what force means, okay? So Tao, can you share what you said again? And T, as she says it, I'd like you to be listening to what she says, okay? Right. Okay, so T, are you listening? Okay, so did you hear what Tao said? Okay, what did Tao say? Okay, so then that's exactly what a force is, right? A force is a push. So can you demonstrate a force for me, T? Are you able to push something? There you go, that's a force, right? She just exerted a force on that. Okay, but forces can also be something else. Anybody else think besides pushing, we can exert a force in another way?
Energy.
No, you could also pull, right? So I could push, or I could pull on something. All right, so we're going to be talking about how forces interact with rockets. Right? How can we use a force to make a rocket do what a rocket does? All right, so we're going to start with a quick little video about one of the rockets that humans have launched into space. As we watch this video, I want you to do two things. Okay, I want you to come up with something you notice. All right, so a notice and a wonder. Okay, so a notice is just a comment, something that you see, and a wonder is like a question that you have. So you understand? A notice and a wonder. You don't need to write it down unless you really want to, but you need to be able to answer it afterwards with one thing you notice and one thing you wonder. All right, we ready? Here we go.
7, 6, 5, 4, 3, 2. Engine ignition. And liftoff. Liftoff of SpaceX's Falcon 9 rocket, launched Dragon on the 25th mission to resupply the International Space Station with cool science and a new advanced instrument to more effectively study our planet's climate.
call out for maximum dynamic pressure.
Okay, we'll pause it there. Again, we're looking for one thing we notice and one thing we wonder. Do we want to watch it again to come up with these, or is that enough time for you to have a notice and a wonder? Do you need to watch it again? No? See? Can you think of a notice and a wonder? So let's try everybody else first. Something you notice. Can you tell us something you noticed, Tuck? Okay, so you saw fire, and it made the rocket go up. Okay, so that's something you noticed. Okay, Mary, is there something? What was something you noticed?
Same thing, rocket going up with fire beneath.
Okay, so notice that there was a rocket going upwards with some fire beneath. T, is there something you noticed? That's maybe different from what everybody else said?
Why when the rocket goes up, there's like dust there?
There was dust. Okay, so that's a wonder, right? You're asking a question. It's a really good question. So why, when the rocket goes up, is there dust all around it? Is that your question? Okay. Now we're looking for another question. Now, do you have a question? How can we use fire to make the rocket go up? Okay. And Mary?
Something with fire too. Why was there fire on the bottom?
Okay, so why is there fire underneath the rocket? All right, so what we're going to do with today's lessons is we're going to learn some of the science behind it, but we're also going to build our own rocket out of a plastic bottle, and our rockets are going to shoot up just like that one did. Okay, so next thing is we're going to do something called a anticipation guide. So we have 4 questions here that I want you to do on your paper. I'd like you to write the number 1 through 4. Right, so you can write 1, 2, 3, and 4. I'm going to tell you a little story for each one, and I want you to say true or false. So true is like this person is telling the truth, and false is like this person is lying. Understand the instructions? It's okay, don't worry about it, T. Just keep going. We know it's a 2. Okay, so once upon a time, there was a guy named Aristotle. And Aristotle said, all objects want to be at rest. So no matter what, all objects eventually will come to a stop. Right? So, as an example, if I push this bottle, Aristotle said it's moving, but eventually it will come to a complete stop. That's what Aristotle said. True? Is he telling the truth? Or false? Is he lying?
T or F?
T or F? On number 1. What do you think, T? And again, don't share your answers with anybody, right? I want to know what you think.
Right.
It's okay to be wrong, right? We're just thinking all objects will eventually stop, or no? Okay, 5 more seconds. Please write something, T. T looks like this. Right? F looks like this.
Yeah, but which one's
T is for correct, and F is for wrong. T is correct, F is wrong. Okay, next one is, there's a guy named Galileo. Galileo really liked throwing things off of buildings and see how fast they fell. And Galileo said, if an object is moving, it will keep moving forever in a straight line at the same speed. So Galileo said, if something is moving in a straight line, it will continue moving in a straight line unless some other force acts on it, unless something pushes or pulls on it. What do you think? Galileo was telling the truth, or was he wrong? And? Okay, so you choose what you think. And then the third one is, when a rocket lifts off, it pushes against the launch pad. So the launch pad is what the rocket's sitting on before it launches up. And then it also pushes on the air so that it gets higher and higher. So a rocket, so here imagine this is our rocket. What this thing is saying is that when the rocket is taking off, it's pushing down on the ground, and it pushes on the air to make it go up. That's what's causing it to go up. What do you think? Is that true or is that false? All right, and then the last one is a spaceship or a rocket ship like the one we just saw. It doesn't move at all on average. It throws part of its mass one way, and it goes the other way. But on average, its mass is not moving. So what do you think? Does a rocket on average move or not? True or false? Like overall, the mass of the rocket is moving or not moving?
Moving.
So moving would be false, not moving would be true. Moving is false, not moving is true. Okay, and so